The Sun makes up 99.75% of all the mass in the solar system, and so it shapes the behavior and orbits of everything else in it. Billions of years ago, after the Sun was born, the solar system was a chaotic and dangerous place as the planets were formed from countless little pieces that collided constantly, but over the eons a stable balance emerged. Today most planets and asteroids have settled into safe and predictable orbits. Subscribe and like for more about the cosmos. We have the inner and outer planets, the asteroid, and at the edge the Oort cloud, a giant sphere of comets orbiting slowly in cold storage. We really don't want this balance to be disturbed. If another star came too close to us, its gravity would put on everything in the solar system like a spoiled toddler, messing up the pleasant order of the planets and asteroids and comets. This isn't some imaginary danger. Some 70,000 years ago a red dwarf binary system passed through the Oort cloud and messed things up. It might even have sent a deadly onslaught of asteroids our way, but it could take 2 million years until those visitors from the Oort cloud arrive in the inner solar system. But there's a much bigger problem on the horizon. Gliese 710, a red dwarf with about half the mass of the Sun, is currently headed towards the solar system. In about 1 million years it'll pass through the Oort cloud and become the brightest star in the night sky. A close flyby like this would unfold over hundreds of thousands of years, disrupting the orbits of millions of objects in the Oort cloud considerably. If we're unlucky, it will trigger a new period of planetary bombardment similar to the early solar system. The galaxy could be filled with comets and asteroids raining down on the inner solar system. The larger ones could cause dinosaur-level mass extinctions and would be bad for the stock market, but it could get much worse. The galaxy is an intense place and stars get close to each other regularly, so it is possible that a star could come much closer and not just pass us, but fly directly through the inner solar system. This would be very bad in the extreme of another star colliding with the Sun. Is astronomically unlikely, but that isn't what we're worried about. If another star were to pass by about as close as the Earth is from the Sun, it could easily eject the Earth from the solar system. The odds of such an event are estimated to be around 1 in 100,000 in the next 5 billion years. Small, but not absurdly so. As we discussed in another video, there seem to be billions of rogue planets doing their own thing in the galaxy, and this is one way to make them. So if this were to happen with an average red dwarf, what would happen on Earth? Kicking Earth out of the solar system. As the star enters the solar system, a small orangish dot appears in the sky that grows bigger and bigger for months, eventually becoming visible during the day. It would get bigger and much brighter than the moon. Too bright to look at directly. The night sky would be filled with an eerie red glow. After a few months, it would start shrinking again. But so would the Sun. Over a few years, the Sun slowly grows smaller in the sky, and with it, warmth and light start to dissipate. All around the world, as the days turn dark, the final winter of humanity would begin. The polar ice caps begin to grow and spread, while plants shrivel and die. Forests freeze, and animals die in droves. As the Earth passes the orbit of Mars, from space, Earth begins to look like an icy moon, the blue-green surface becoming the pale grey-white of death. As global infrastructure breaks down, people huddle together indoors, burning what they can for warmth, as the temperature continues to drop, counting the days until they'll be out of food which no longer grows. Everybody living at the surface is living on borrowed time. By the time Earth reaches Jupiter's orbit, surface temperatures sink to -150 degrees Celsius, lower than the coldest ever recorded temperatures in Antarctica. Needless to say, by now almost everyone is dead. Without the energy from sunlight to evaporate water, clouds don't form, and the water cycle stops. The polar ice caps eventually touch at the equator, and the oceans become covered in a thick layer of ice. As more and more of its heat leaks out, more water freezes onto the bottom of the ice sheet, the concentration of salt in the deep ocean grows, poisoning most animals that survived here. Although around hydrothermal vents, communities of extremophiles might adapt even to these circumstances. Deep below the surface, some bacteria would not notice much of any of this, as they're still kept warm by the radioactive decay of elements in the Earth's core. As the Earth reaches the orbit of Pluto and the Kuiper belt, the Sun is still the brightest star in the sky, but it's one among many, with stars now visible during the day. The temperature is now barely 40 degrees Celsius above absolute zero, below the freezing temperature of the gases in the atmosphere. A weird spectacle, enjoyed by no one unfortunately, unfolds as the atmosphere turns into nitrogen and then oxygen snow. Over a few years, it's deposited into an icy 10-meter thick sheet all over the planet's surface, with only a thin whisper of gas remaining. The frozen corpses of flora and fauna are buried beneath them. As Earth leaves the solar system, it becomes a rogue planet, traveling alone through the dark, lifeless and in solitude. But weirdly enough, there is hope. Humanity would not be surprised by this potential extinction event. We'd notice it thousands of years in advance. There's not a lot we could do to stop a star, but we could prepare. Most of us would perish, but a few million could survive in huge artificial complexes, powered by geothermal and nuclear energy, possibly even fusion if we can learn to use the ice around us for power.